Industrial 3D printing is changing the way companies develop products and devices. With prototypes in hand within days, designers and engineers can iterate and validate designs faster than ever before. And since parts are manufactured in commercial-grade materials, 3D printing is even being used as a production method for end-use components. So how does the technology work? Where does it fit in product development cycles? And how can you leverage 3D printing to its fullest potential?
We really take pride in making better quality parts than anybody running even the same equipment that we're running.
We take an approach that we want to be able to manufacture the same part across all machines, and the way that we manage that is through just rigorous preventative maintenance on our equipment. We constantly make improvements to our maintenance schedules, our calibration routines on the machines. We're really pushing our ultimate goal, which is to build a part across an array of machines with the same outcome.
We have checklists associated with absolutely everything. Our folks who are preparing builds to go onto the machines know what removing the support structures or breaking out a part from the machine is like, so they know what that end product's going to be, so they get a better understanding of why this person set the part up that way, why this little piece of support structure is where you don't want it to be because it's hard to get to. Well, there's a reason for it, and we make sure our people understand where those come from.
Once your order is placed, it's reviewed for issues by technical staff. And we're performing offsets to the CAD file to ensure the part's as accurate as possible. Depending on the printing tech, we're adding support structure to the part to capture all the down-facing surfaces, possibly tilting the part to control warping issues. It's then sliced into the thousands of layers, and that data is then pushed out to the printer for the part to be built. Among 3D printing processes out there, all of them, stereolithography really excels in small feature resolution and tight tolerances and smooth surface finishes.
Stereolithography was very early on adopted by the medical industry. So we do a wide range of medical devices, medical instruments.
Probably the largest benefit of SLS specifically is the fact that this is an actual thermoplastic material, so it exhibits much better mechanical properties. A large percentage of our parts are for customers that are doing injection molding, but they realize they can take advantage of the reduction of components with snap fits, living hinges.
SLS, you see more end-use functional prototypes where maybe surface quality isn't as much of a desire for the customer when they want to do good form and fit functional testing.
A good use of DMLS technology is reduction of components. So any way that you can reduce the assembly time, reduce the part count, is going to in turn reduce the cost of the process. Anything that goes up in the air adds weight, and weight adds fuel and cost. So reduction of components is very key in the aerospace industry for that reason.
The density of the DMLS parts is going to be very comparable to a billet or machined metal part. Strength properties and all the different specifications are also going to be very close to what you would see out of a machine or even die-cast part.
We differentiate ourselves from desktop 3D printers because we're running industrial level equipment, and we have a process engineering staff that maintains the process and the machines to a very high level, and we're able to produce very high quality parts with that that are very reproducible order to order and customer to customer.
Protolabs is a technology agnostic company. We have over 70 pieces of industrial 3D printing equipment. We are open to using any manufacturer's equipment, assuming it meets the guidelines and quality that we want for our customers.
An advantage many of our customers get from this technology is the reduction in inventory they need on hand. Rather than stockpiling a ton of parts multiple years in advance, they can order on demand as needed.
Product development is first and foremost quick turnaround, getting near fully functional parts right off the machines. You're turning product design iteration times around in days instead of weeks.
Ready to elevate your product development cycle with industrial 3D printing? Get 1 to 50 plus prototypes and production parts in as fast as 1 day at Protolabs. If you have a CAD model ready, upload it today at protolabs.com for an instant quote with real-time pricing info and design feedback.